So, hello everyone. Today I am going to deliver a lecture on residual stresses measurement techniques. So, last class I was discussing what are the different factors affecting residual stresses, as well as what are the different types of controlling method are there to control the residual stresses. So, today I will discuss different types of experimental methodology which are commonly used to predict the residual stress in details. So, this is the content of today's presentation. First of all, I will discuss categories of different types of residual stress measurement technique. Then I will discuss measurement of residual stresses by using some stress relaxation techniques in these topics which I will cover. Now, you see we know that residual stress are very difficult to measure, because what happens, this is a locked in stress. So, what happens, we have to remove that block first, then only what happens, we can measure that residual stress. That is why what happens, there are different types of measuring techniques are there. Though that measuring techniques are there, but what happens, with any real accuracy, it is very difficult to measure. This you should keep it in mind. There are different types of categories of residual stress measurement techniques. So, in general we can categorize this residual stress measurement techniques in three different categories. One is called destructive technique, another one is called semi-destructive technique, another one is called non-destructive technique. So, in today's lecture I will first introduce what is this destructive technique, semi-destructive technique and non-destructive technique. After that I will just in details I will discuss the experimental methodology of residual stress measuring technique. So, you see the destructive techniques are those techniques which result in a large and irreparable structural change. This you should keep it in mind. So, once we go for measuring the residual stress by destructive technique, so at that case generally large and irreparable structural changes occur. So, what happens, that is why meaning that either the specimen cannot be returned to the service. So, here we destroy the structural integrity, that you can say. So, there are different types of destructive techniques which are popularly used to measure residual stress. This destructive technique especially based on strain release principle. Strain release principle, what does it means? What I have told you, I have told you that okay, residual stress is locked in elastic strain. The residual stress is generated due to lock in elastic strain. This you should keep it in mind. So, residual stress is a elastic type of stress. That is why once we just remove that locking, then what happens, it release. What I am telling, understand? Like what let us consider here, this is a body which is stressed, by due to some load, let us deformation load. So, after a stress, what happens, let us after a stress, let us we provide some top layer and we provide some bottom layer to prevent to return back this body to its original shape. Then what happens, this will remain as the elongated state condition. That means, inside this inside this bar, this hash bar you can say, where generally we have applied some deformation. So, it will be remain as it is. Now, once we remove this support from this bar, it will return back to its original length L0, you can say. Let this is the final length, and it so once we remove this support, then it will return back to its original length. That means, it releases strain, what I am telling, understand. So, this release strain generally measured in destructive types of welding technique, because what happens, due to this what it is called elastic strain, there was some what it is called stress. That stress was locked in stress, and that stress is called what it is called residual stress. Now, how to measure how much residual stress was there? So, once we just make some procedure by which if we can just release that part from that support, surrounding support, then it will return back to its original position. So, what happens that how much returning back to its original position is happen, if we can measure that part, then what happens, we can easily measure the what it is called how much residual stress is there. So, this technique use strain release principle technique, this you should keep it in mind. So, there are different types of destructive residual stress measuring techniques are there. One is called contour method, another one is called slitting method, another one is called block removal or splitting or layering method, and another one is called shaft boring techniques, okay, by which generally we can measure the residual stress where we have to destroy the structural integrity, that means we generally destroy the specimen, this you should keep it in mind. Okay. So, here this methodology details I will discuss in subsequent slide in details. Like contour method, it is generally used for residual stress on a 2D plane. Say this 2D plane generally we cut by using some wire EDM technique, that means EDM techniques we generally cut this specimen. Due to this cutting of a specimen, whatever the stress will release, then what happens, by this we can measure the strain. So, from this strain, once we multiply the strain with elastic modulus, then we can get the stress, that is very well known to you. Another method is called slitting method. This method, instead of 2D plane, this method is used to measure through the thickness of the specimen, this you should keep it in mind. So, here a cut is made which is at a normal, that is called slit. So, by this slitting operation we generally measure the residual stress through the thickness of the plate, okay. This you should keep it in mind. And block removal, splitting, layering technique, this is also more or less similar types of technique that I will discuss in detail in subsequent slide. Now, semi-destructive technique. What is semi-destructive technique? Semi-destructive technique is more or less similar to destructive technique, but what happens here, generally the removal of means material, or you can say they remove only a small amount of material, leaving the overall integrity of the structure intact. That means, here structural integrity is remain as it is, you can say, because here only a small amount of material is removed. What I am telling, understand? That means that here we can reuse that structure, this you can say. But here the principle of this measuring technique is similar to destructive types of what it is called destructive type of residual stress measurement technique. That means, here also we use strain release principle. Strain release principle means what happens, this is a body which is subjected to some deformation. So, after deformation let the shape is become like this, after that we fixed this deformed part. Now, if we just cut this dotted layer, this dotted length was this much. So, once we cut these things, it will return back to its original position. Or initially that means this initial cut length was this, due to this elastic strain. Once we just cut through this section, it will return back to this final length, that means here this is the final length LF, okay. This you should keep it in mind. That means, once we cut this thing, it release and it is shortened if it is what it is called, if it is elongated. Now, if it is compressive due to this locked in condition, then what happens, if we just cut that position, it will elongate it. This you should keep it in mind, okay. So, depending upon the locked in stress, that can be tensile, that can be compressive. So, depending upon this tensile and compressive strain, the residual stress also can be tensile, residual stress also can be compressive in nature. This you should keep it in mind. So, this semi-destructive techniques, here there are different types of semi-destructive residual stress measurement techniques are there, like one is called deep hole drilling technique, another one is called center hole drilling technique, another one is called ring core semi-destructive residual stress measurement technique. Deep hole drilling techniques, here generally we can measure the residual stress through the thickness, this you should keep it in mind. Okay. So, through the thickness we generally gradually what it is called release the strain, and that strain we can measure by using some specially designed strain gauge, especially designed strain gauge. That strain gauge can electrical strain gauge or mechanical strain gauge. Especially for default drilling techniques, we use some what it is called mechanical types of strain gauge. How it is, that I will discuss in subsequent slide in detail. Okay. By releasing the stresses in a core which is surrounding a small diameter drill hole, this you should keep it in mind. Okay. Now, center hole drilling technique, how it is, that I will discuss in subsequent slide in details. Center hole drilling technique, it measures the near surface residual stress by releasing the strain corresponding to a small shallow drill hole with a strain gauge rosette. That means, so default drilling techniques, there is through there we generally measure the residual stress through the thickness, but center hole drilling techniques measure the residual stress near the surface. This you should keep it in mind. What happens here in this case, let us say body which is generally which is subjected to some residual stress. So, if we just make some hole in this body, then what happens, that the stress part will be just cut. So, once this stress part will cut, then it will return back to its original position, correct. Once it returns back to its original position, how much returning back is taken place, that is generally measured by using some strain gauge. Strain gauge, you know that strain gauge is you can say electric types of thin wire which have some conductivity as well as conductive resistance. What happens, once it is subjected to some strain release, then this what it is called strain gauge wire is subjected to expansion or contraction. So, once this expansion and contraction occur there, due to this thing what happens, there is occur some resistance change. Once this resistance change occur, that resistance we calibrated as a strain value. So, from there generally we can easily measure the how much strain is releasing by using this strain gauge. So, center hole drilling technique generally measure near the surface residual stress, default drilling technique measure the through thickness residual stress. Now, ring core method, this technique is similar to what it is called default drilling, that is center hole drilling technique, but here the difference is here with greater penetration is occur, and with the cutting taken place around the strain gauge rosette rather than what it is called through its center. This you should keep it in mind. So, in center hole drilling technique, there the hole is drilled generally in between, you can say is in between the strain gauge, but in case of ring core techniques, this is a specimen. Now, what happens here, generally a strain gauge is placed, or you can say strain rosette is placed, this strain rosette have some external wire. This is generally connected to some electrical device, or you can say data logger system. So, here in case of ring core method, here generally the cutting is done around this strain gauge rosette, okay, around this strain gauge rosette. This you should keep it in mind. Whereas center hole drilling technique, here the strain releasing operation or hole is made in between, that means at the middle of this strain gauge. Okay. Let us, there is 3 strain gauge like this. Strain rosette generally consist what it is called 3 different strain gauge. So, these are let us 3 different strain gauge. Okay. So, in case of center hole drilling technique, here the hole is made at the center, whereas these are called strain gauge. Once we make the hole here, then what happens here, the strain layer, or you can say strain component will release this strain and it will return back to its original position. Now, if this strain gauge is placed over the surface in such a way, so that once this releasing of this strain occur, Due to this releasing of strain occur, this strain gauge is subjected to some expansion or contraction. This strain gauge is subjected to some expansion and contraction. This expansion and contraction generally correspond to some what it is called resistance change. Due to this resistance change we calibrated in terms of strain. From that strain we can easily measure the what it is called residual stress. This you should keep it in mind. So, in case of center hole drilling techniques, the hole is made at the center of this strain gauge, but in case of ring core method, the hole is made around the you see strain gauge rosette. So, here the hole is made around the strain gauge rosette. Strain gauge rosette, what is called strain gauge rosette? Once it is a system of what it is called strain gauges. Generally, there are used 3 different strain gauges. They are used generally in a strain rosette. There is used 3 strain gauges with different orientation. Depending upon this orientation, we can categorize this strain gauge like 45-degree strain gauge, then what it is called 60-degree strain gauge. 45-degree strain gauge, how it look like, just little bit I am just showing. So, this is a system of strain gauge, where generally the strain gauge is put, one is horizontal axis, another one is just 45 degree with this horizontal axis. So, 3 strain gauge generally used in a strain gauge rosette, because once we use this 3 strain gauge, then we can easily measure the principal strain, principal stress in detail. How it is, that I will show you. So, this 3 strain gauge is used, as this strain gauge is placed 45 degree apart from each other, that is why it is called 45 degree strain gauge rosette, strain rosette or strain gauge rosette. There can be 60 degree strain gauge rosette. So, 60 degree strain gauge rosette, how it is? So, one is horizontal, one strain gauge is horizontal, another one is just 60 degree angle with this horizontal axis, and another one also you see we have a 120 degree with horizontal axis, but if we take this angle, so this is 60 degree, this is 60 degree and this is 60 degree. These are all called strain gauge. Okay, these are all strain gauge. This you should keep it in mind. Okay. So, this strain gauge depending upon the position, once it considers 3 different strain in a particular orientation, that is called strain rosette. This you should keep it in mind. This is called 60 degree strain rosette, this is called 45 degree strain rosette. Okay. These are very commonly used to measure the strain. So, once we measure the strain in by using this strain rosette, we can easily measure the principal strain. How it is, I will show you in subsequent slide. So, another technique is called non-destructive residual stress measurement technique. In this technique, generally the effect of relationship between the residual stress and their action of crystallographic property of the material we measured. This you should keep it in mind. So, here in the non-destructive technique, the structure is not subject to any types of destruction. So, here only we measure the crystallographic property changes. So, once this crystallographic properties changes, that means once a material subjected to some residual stress, it is observed that there is occur some crystallographic changes. So, what is the relationship between this distorted you say crystallograph with the residual stress? That relationship once we can find, then we can easily measure the what is the residual stress. That principle generally here we use. That means, how the crystallographic change occur once a material or once a body is subjected to some residual stresses. This you should keep it in mind. Some of this work generally where we generally measure the diffraction of high frequency electromagnet radiation through the atomic lattice spacing. So, this diffraction we measure both without residual stress specimen as well as with residual stress specimen. After that, generally from the difference of this with residual stress diffraction of electromagnetic radiation and without residual stress specimen diffraction of electromagnet radiation, by comparing these things we can easily predict the how much residual stress are there. So, here generally we use generally diffraction of high frequency electromagnetic radiation, which is occur through the atomic lattice spacing. This you should keep it in mind. So, I will discuss this thing in details in subsequent slide. Generally, there are different types of what is called non-destructive residual stress techniques are there, like neutron diffraction residual stress technique, then synchrotron diffraction technique, X-ray diffraction techniques, and there are some other non-destructive residual stress techniques are also there, which somewhere we use acoustic property, somewhere we use ferromagnetic property of material. So, this where we use acoustic property of material, there that is generally commonly known as ultrasonic residual stress measurement techniques, and somewhere where we use ferromagnetic property of material, that is called magnetic residual stress measurement technique. So, about this in details I will discuss in subsequent slide. So, here I am just showing the commonly applied residual stress measurement techniques, because that is why about these techniques I will discuss in details in this course. Most of the topics I will try to cover, how that means this measurement technique which are commonly used in practice actually. So, that related topics I will discuss in this course in details, like the techniques which are commonly used, which are stress relaxation techniques. It is a destructive technique. So, here these are the different technique name I have shown, whatever the name I have provided earlier also, this name is similar to, more or less similar to this, but what happens depending upon some inventor name, these techniques also have some different name, like what happens the techniques which I will discuss here, like sectioning technique using electric resistant strain gauge. I will discuss about Mather Swete drilling techniques. I will discuss about Gunnart drilling techniques. I will discuss about Rosenthal Norton sectioning techniques. I will discuss about what is called surge boring techniques, then deep hole drilling techniques. I will also discuss here different types of NDT testing, that is called X-ray diffraction technique, then neutron diffraction techniques. I will also discuss about these ultrasonic techniques. But what happens Beetle coat method and photo stress techniques I may discuss if the time permit, if time will not permit I will not discuss in this course. This you just keep it in mind, that means these techniques and this technique. So, first of all I will discuss measurement the residual stress by using stress relaxation technique. So, first of all I will discuss about sectioning using electric resistant strain gauge, how it is here you see. So, here generally this electric resistant strain gauge are mounted, here you see this is one electric strain gauge, this is another strain gauge which is mounted on the surface of the test specimen. Let this is the test specimen at which we want to measure the residual stress. So, this is the position of this strain gauge, this is the top view of these things. Now, here in case of sectioning using electric resistance strain gauges, here generally we use to remove the specimen by using what it is called trepanning technique. Trepanning technique generally remove the makes a what it is called bore types of hole, how it is I will show you. Okay. So, here a small piece of metal containing the strain gauge, you see this is a here you can see this is a circular types of cut we make. Here you see this is circular types of cutting is made by using trepanning operation. Trepanning generally consists a hollow circular tool in the sense you see this is a hollow circular tool you can say. So, this is hollow cutting tool. So, what happens, what is hollow cutting tool? Due to this hollow cutting tool it generally cut around the specimen, what I am telling understand. Here you can see this strain gauge is placed inside this hollow cut. you see this is the cutting section, this is the cutting section, you can see this is the cutting thickness, you can say. This cutting is done by using this, what it is called, by using this hollow cutter. So, this is called trepanning cutter, you can say, trepanning cutter. So, trepanning cutter is a circular types of hole, you can see circular types of hole. So, it is a hollow circular hole. So, it generally cut around this cutting edge. So, like this, here the cutting edge. So, a small piece of metal which containing this strain gauge is removed by using this trepanning operation. So, we just remove that portion from this, what it is called, from this specimen. So, once we remove or cut this portion or this specimen with a strain gauge, then once we just cut this thing, then whatever the strain was there in that specimen, that will release. So, due to this thing, this specimen containing this strain gauge will subjected to either expansion or contraction. Due to this expansion and contraction, whatever the expansion contraction will be there, this electric strain gauge will expand or contract. So, that means how much expansion and contraction of that strain gauge is there, that generally we measure by using some data logging system. So, from there we can easily measure how much strain was there. So, from there we can easily find out what it is called, we can easily find out how much stress was there. So, you see this is generally measured by using a strain gauge. So, a strain that take place during the removal of the specimen is determined by this technique. Say here generally the strain measure which was released, the released strain means this is a elastic types of strain, this you should keep it in mind. So, once we can measure this elastic strain, by this we can easily measure the residual stress. How it is, that now I will show you. Now, we know that in a 2D plane generally we are measuring the strain, we know strain at any direction, let this is your x direction, this is or y direction. So, we know a strain at any direction, let us a body subjected to, this is a body, just I am just showing here, let us this is a body which is subjected to some strain in x direction, which is subjected to a strain in y direction. Now, if it is a 2-dimensional case, then what happens along any other direction, let us this is a direction which makes angle theta with horizontal axis, in any other direction what should be the strain distribution, that we can easily find out. That means, we can easily find out epsilon theta, let this is in this direction strain is epsilon theta. So, epsilon theta we can easily measure as by using a derived formula, I am not deriving here, epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta plus gamma x y by 2 sin 2 theta. This you should keep it in mind, where gamma x y cause shear strain. Okay. To measure a strain at any direction, we can use this formula, that means we can use this formula. Now, by using this strain gauge, whatever the strain gauge I have shown previously, by using this strain gauge, like what happens, you can see. So, you can see we generally use a strain gauge which I have shown in previous slide. This has generally 3 strain gauge, that is called a strain rosette, you can say. So, this is the strain gauge we use there. So, this first strain gauge which have a direction with x direction, let this strain gauge have a direction with this what is called, this strain gauge have a direction, you see, with this strain gauge have a direction with x axis is theta, but this strain gauge have a direction with x axis, you can say x axis is let us phi. So, at different direction we can get the strain value. So, this so first one, this will give you the epsilon x directly, how it is you can see. So, here, so this is for this strain gauge 1, for this strain gauge 1, let this is the strain gauge 1, this is the strain gauge 2, this is the strain gauge 3. So, here you see in this epsilon theta there is also 3 unknown, epsilon x, epsilon y and gamma xy. Now, strain gauge generally used in a 2D plane, that is why here we are considering 2D case, that means epsilon x and epsilon y only. This you should keep it in mind. Epsilon z we are not considering, because strain gauge generally used to measure the strain in a 2D plane. So, here you see what you can what we can do, we can easily measure this epsilon x value, because how this epsilon x we are coming here for epsilon x, actually we are getting when theta equal to 0. Just you put the theta equal to 0 here in this equation 1, in this equation we put the theta value. This is very, this equation 1 is very well known to you, you can derive it actually, this is very simple, I am not going in details here. So, here this is 0, epsilon x minus epsilon by 2 cos 2 theta, as theta is 0. So, this will be 1 plus 0. So, here you can see this is coming epsilon x. So, this strain gauge 1 will give you epsilon x. Similarly, epsilon let us another strain gauge, if we use let us theta equal to 90 degree. So, in this case we will get epsilon y, okay, correct. Now, let us another angle is there, epsilon theta equal to let us 45 degree. Okay. So, in this case another relationship we will get. So, now here you see, if we just put all these value by using this relationship, we can easily measure this gamma xy, that means shear strain component also theta 45 degree or whatever it is. So, by this strain gauge will give you some value. So, that value is known to us, by putting that value here we can easily find out these 3 unknown gamma xy, epsilon x and epsilon y, correct. You got the idea from this, because here 3 equation. So, 3 known data we are getting by a strain rosette which is containing 3 strain gauge. So, by this we can easily measure this epsilon x, epsilon y. Here generally we used to find out the what it is called stress by using generally in a plane stress condition, because here we are not considering the through thickness, that is why what happens here we have to use plane stress types of condition. So, in a plane stress types of condition generally here what it is called through thickness stress is generally not considered. So, here 2 dimensional case only we are considering. So, for finding out now stress, we know that epsilon x is equal to you can write as sigma x divided by E minus mu into sigma y divided by E. So, we got already this epsilon x, epsilon y by using this strain rosette system. Now, how we can find out this sigma x and sigma y, correct. These 2 stress we are interested to find out. These 2 stress will give you the stress along x axis and stress along y axis. Now, x axis along x axis, if the welding is done, then what happens, we will get longitudinal stress, and along y axis it will be perpendicular to the welding direction. So, it will give you what is called, it will give you transverse stress. So, that also I will discuss in subsequent slide in detail. So, epsilon x will give you sigma x by E minus mu sigma y by E, how it is, that also I will show you. So, you see due to this x axis this body will elongate like this. So, due to this elongation you can observe from here there is occur a length increment, but what happens, there is occur a breadth decrement. So, initially the breadth was B0, final breadth was let us BF breadth or width you can say, but initially this length was L0, that final length become let us LF. So, by this generally we can get 2 different types of strains once a body is subjected to particular types of stress. So, one is called linear strain. Linear strain means along the loading direction whatever the strain is occur, that is called linear strain. So, linear strain we can write as change of length, that means LF minus L0 by its original length, this is called linear strain. Another one is along this width direction also there is occur some shortening types of phenomena, that is called lateral strain, that is called lateral strain. So, lateral strain how we can write? Here you see change of breadth by its original breadth B 0. That means B f minus B 0 by B 0, this you can say. Now, you know that Poisson's ratio mu, or it sometimes represent as nu, this Poisson's ratio mu equal to your lateral strain divided by linear strain. This you should keep it in mind. Strain divided by linear strain. Okay. Now, you see, so from here generally you can easily get this Poisson's ratio. This is called Poisson's ratio. Poisson's ratio, this you should keep it in mind. Now, if a body subjected to both sigma x and sigma y, then what you can see, what you can say? So, we also from Hooke's law, here from Hooke's law we know, from Hooke's law, here you see, from Hooke's law we know that sigma is proportional to a strain, that means a stress is proportional to a strain till proportional limit, till you can say till proportional limit, this you can say, or you can say this proportional limit generally sometime coincide with elastic limit, that is why it is called elastic limit. That means, at a local point from where once we remove the load or release the load, it will return back to its original position, that is elastic limit actually, or proportional from proportional limit also generally this is return back to its original position. Sometime it is coincide with elastic limit, that is why it is called proportional limit, also sometimes considered as elastic limit, because once it coincide with each other, this you should keep it in mind. So, from Hooke's law we know stress is proportional to strain. So, this we can write as sigma equal to your E into epsilon, correct. So, from here we can easily find out epsilon is equal to your sigma by E. So, strain equal to, we can easily find out sigma by E. Now, if it is if there is a sigma x stress, so here sigma x, then your epsilon will be your epsilon x, correct. If it is sigma y, then that will be epsilon y. Now, here another things you should keep it in mind, due to this sigma x, itself, there is occurring some another strain which is other direction. So, you can say due to this sigma x, whatever the strain will develop. So, here I am just writing sigma x, here you can see this mu you can write as epsilon y by epsilon x, correct. This you can write. So, from here you can write epsilon y is equal to, if it is due this thing is occurring due to sigma x. So, epsilon y you can say as mu into epsilon x, correct. This you can write. So, epsilon y will be due to this sigma x, you can write mu this sigma x divided by E, correct. So, epsilon y from here. So, if a body subjected to only one types of load, you see due to these things in that body there is occur a lateral strain, that is epsilon y, and as well as there is occur a linear strain, that is epsilon x. This you can see, this you can see. Now, you see this epsilon y direction generally once this epsilon x is elongated, then epsilon y is decreased, that means decreasing, what I am telling, understand. So, here this epsilon x overall, if a body subjected to now both the stress sigma x and sigma y. So, sigma x and sigma y. So, due to this sigma x there will be a linear strain along x direction, correct. So, let us I am representing this is the overall strain along x direction due to this two stress condition, that means sigma x and sigma y. But this sigma y will try to reduce this length direction, that means this is the length and this is the breadth. Okay, this I am just writing. So, whatever the portion of reduction of this strain will be there, this due to this sigma y, this we can write mu into sigma y by E. How it is coming, that I have already shown here, you just keep this thing in mind. So, overall epsilon x will be your sigma x by E, and due to this sigma y and its Poisson's ratio, there will be what it is called, there will be a shortening of the length along x direction, that is why this negative sign is coming. Similarly, epsilon y dashed, that means along epsilon y direction there will be overall strain, let this is the overall strain due to this combined loading sigma x and sigma y, because a body is subjected to both sigma x and sigma y, then what happens? So, sigma y, due to this sigma y force along y direction there will be a epsilon y, and what happens due to this sigma x also there will be a strain along y direction, which is equal to your minus mu into sigma x by E, correct. This you just keep it in mind. So, how this overall strain along x direction and how this overall strain in y direction is coming due to two different loading condition, that idea you got. Now, what happens, we can easily measure this overall strain and x direction and overall strain in y direction by using this strain gauge rosette, this strain gauge rosette. So, we got these things. Now, we know the Poisson's ratio of this material, this Poisson's ratio is of this material is known to us, okay, this known to us. Now, we have to find out what is sigma x and sigma y. How we can find out this thing? This thing we can easily find out by just solving this two equation, let this is equation number 1, this is equation number 2, correct. Now, here just I am multiplying the equation by mu, okay, and here multiplying by 1. Now, what we will get? So, here we are getting sigma x dashed into mu into sigma x dashed is equal to your sigma x by E minus mu into sigma y by E, this is mu a square, and here will be epsilon y dashed, which is overall strain due to the combined effect of sigma x and sigma y along y direction. This you should keep it in mind. Okay. So, this will be your f sigma y by E minus mu sigma x by E. Now, add these two equation, what you got? You will get you see this and this will cancel out, this and this will cancel out. So, here you will get mu into epsilon x dashed minus epsilon y dashed will be your what is called sigma y by E 1 minus mu a square, correct. So, here what you can get? You can get sigma y by E is equal to your epsilon y dashed plus mu into epsilon x dashed, correct, divided by 1 minus mu a square. So, from here you can easily get sigma y is equal to your how much? Epsilon E into E by 1 minus mu a square E into 1 minus mu a square epsilon y dashed plus mu into epsilon x dashed. Okay. This is sigma y you are getting. So, sigma y you are getting. Now, we will see what is sigma x. So, sigma x we will get by using the previous two equation, that will be your E by 1 minus Poisson's ratio square into epsilon x plus mu into epsilon y dashed. Okay. This you just keep it in mind. So, sigma y you got as E by 1 minus mu a square, this is epsilon y and this is your epsilon x dashed. So, once it is sigma x, then there is a epsilon x dashed, once it is sigma y there is epsilon y dashed, this you just keep it in mind. So, by using these two equation we can easily find out what is the stress distribution along x direction and what is the stress distribution along y direction. How we are finding out this? We are finding out by using the what it is called by using the strain gauge rosette. You see, for that generally 3 strain gauge we use. So, sigma x, sigma y we find out. Now, we also find out what is the shear stress in x plane y direction. This will be your generally g into gamma xy, because this gamma xy also we can find out by using what it is called strain gauge, which I have shown previously. So, this is called shear modulus. So, once you know this all these things, now you can easily find out what it is called, what is the maximum stress developed in that welded structure or in that structure which is subjected to some residual stress, and what is its direction. How you can find out? If you know this sigma x and sigma y, you know there is a relationship between sigma x, sigma y with what it is called principal stress. That things is very well known to you. I am not going in detail. So, sigma 1 2 the principal stress is equal to your sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y by 2 whole square plus tau x y whole square. So, everything is known to you. By using these things you can easily find out what is the maximum stress developed and what is its direction. How we can find out? So, here you can find out tan 2 theta p is equal to your 2 tau x y divided by sigma x minus sigma y. This is generally called, this theta p is called orientation of maximum principal stress with horizontal axis. That means, let this is your horizontal axis. With this horizontal axis, what is the principal sigma 1 or sigma 2 generally sigma 1 or sigma 2 direction, that you can easily find. Generally sigma 1 if it is say theta p, then sigma 2 will be theta p plus 90 degree. This you just keep it in mind. So, this is called principal stress direction. This theta p is called principal stress direction with horizontal axis. This you just keep it in mind. So, if you know this basic formulation and it is fundamental, so you can easily find out what is the residual stress developed, what is its maximum value and what is its direction. So, this is the methodology generally we use for in stress relaxation technique for measuring the residual stress along x direction, for measuring the residual stress along y direction and its principal stress direction. Now, here one thing you should keep it in mind. Here you see in a body, let us, it is elongated, okay, it is elongated. So, it is elongated, let us, okay. So, after elongation what we did, let us, after elongation we generally restrain its movement, that means we locked it, So, in this elongated part, generally that elongated part means, let this is the elongated surface, this is the elongated surface. In this elongated surface we generally put the strain gauge, correct, we generally put this strain gauge, let us say we put the strain gauge. So, if this elongated part we cut, then what happens, this things will shorten, that means this is the elongated part. Once we cut it, that means once we release this thing, it will shorten, So, what happens, this strain gauge wire also will subjected to some shortening types of effect. So, this strain gauge will provide you what? This strain gauge will provide you compressive types of strain, compressive types of strain. This you should keep it in mind. So, this strain gauge will provide you compressive types of strain. So, but actually this in this structure there was what types of stress? In this structure, as it was elongated condition at that time, what types of stress was there? There was what it is called tensile stress, correct. But what happens, once we cut it, once it release, this strain gauge is compressing, correct, this strain gauge is compressing. So, it record negative things, that means it will compress, means a strong elongated things, once it compress, then what happens, it size will reduce. So, it will give what is called negative types of effect, that means compressive strain. So, that compressive strain generally. So, actually what happens, actually in this body there is tensile stress, but what happens, this due to releasing these things, what happens here the strain gauge will subjected to compressive types of strain. So, strain gauge whatever the thing is recorded, that will be negative things. So, that is why here one thing you keep it in mind, once you go for finding out the strain gauge effect to actual residual stress. So, here residual stress is tensile in nature, but what happens once we measure, once we just cut or release these things, this strain gauge generally will measure compressive types of strain, So, to find out the actual strain, whatever the reading you will get from this strain gauge, with this actually what are the things you have to do? You have to apply opposite sign. So, once you go for finding out the sigma x, sigma y by using this strain gauge, what you have to do? We have to just multiply sigma x is equal to your will be your minus of recording, that means whatever the record you are getting from strain gauge, sigma x into E by 1 minus mu s square into epsilon x dash plus mu epsilon y dash, this you just keep it in mind. So, sigma y will be your minus E by 1 minus mu s square epsilon x dashed plus mu epsilon y dashed. This you just keep it in mind. So, a negative sign will be there. Why negative sign? Because actually this body have a tensile stress, but once it release, the recording will give you negative strain, correct. That is why to get actual stress value, that means how much residual stress is there, whatever the recorded value we will get, with this generally we have to multiply with formula a negative sign. Similarly, your shear stress will be your minus of g into gamma x y, this you keep it in mind. Okay. Next lecture I will start from here. Okay. Rest of the different types of measuring technique I will discuss here. Thank you.